This conference will now be recorded.
Let us start the today's session. Today we are going to discuss a new topic, which is nothing but a generator. Even in our day-to-day life also, we heard about this term so many times in function halls, in cinema theaters, even in your houses also, in apartment, offices, college buildings, wherever you may face a power cut problem. To avoid power interruption, we will use a generator. Am I correct? In our day-to-day life, we may heard about this word generator. Now, my basic question is that a generator can store electrical energy? So, is that a generator will generate current and will it store internally somewhere that amount of current? Is it going to be stored internally? No, not at all. Sir, whenever power is required, whenever current is required, when you switch on the generator, automatically it will start producing the current. So when there is a demand for power, then only generator can start producing the current. If you store electrical energy inside the generator, assume what is the problem? Sir, already generator is generated the current. If it is going to be stored, then what will be the problem? There is a problem that the amount of current we stored, it is going to be dissipated in the form of a heat, and it occupies some space. Several maintenance problems will come. So that is the reason generator, whenever you require power, when you switch on the generator, it starts producing the current. It is not going to store electrical energy anywhere. Then what is the Python's generator? Sir, what is a Python's generator? If somebody will ask you the same question in the interview room, answer them Python's generator. Sir, in Python, generator is a function. Sir, generator is a function. But this function will be having some speciality. Inside this generator, we will use a special keyword. We will use a special keyword, which is nothing but yield. If you find yield keyword in any function, it is not an ordinary function. It is a generator function. Sir, it is a generator function. Sir, what is the main purpose of this generator function is? The main purpose of generator function is main purpose of generator function is to generate sequence of values. Sir, to generate a sequence of values. When you want to generate some huge amount of data, then you can use a generator concept. We didn't understand what is this generating sequence of values, and also some people may have a doubt. To generate a sequence of values in Python, we have some beautiful collection objects, traditional and general collection concepts we have, like list, tuple, set, range function. Then why should I have to go for to generate a sequence of values? Why should I prefer generator function? Let me open Python shell. if I want to generate, sir, there is something called list comprehension. For every x for every x in range of 10, sir, for every x in range of 10, then automatically what will happen, sir, from 0 to 9, because the range is going to start from 0, end value minus 1. Otherwise, better we can take 1 comma 11 boss, 1 comma 11. Then Python internally will create all the objects from 1 2 3 4 to 10, and all these things are going to be stored internally in the memory. They are all going to be loaded into the memory. Then for loop will fetch the values one by one. With that, we are going to create a list, sir, with our built-in collection classes like list, tuple, and set. The problem is, when we want to create a sequence of values, all these values are going to be created at the beginning, and they are going to be loaded into the computer's memory called as a RAM. So whenever there is a demand, whenever there is a requirement to fetch the values from this collection, then you can get them either by using for loop, or you can use while loop as per your convenience. Sir, in this collection type like list, tuple, and set, what is the problem? We could able to generate sequence of values. Then again, to generate the sequence of values, why should I prefer generator? I am feeling much comfortable with this list, set, and tuple. Then why should I prefer generator? Like you may have a doubt. Now the question is, sir, if I want to generate 1000 or 10,000, what will happen? From 0 to 9,999 values are going to be generated at the beginning. All these values are going to be loaded into the memory. Then for loop is going to fetch all of them one after another. Okay, it is okay. Now assume I want to create these many values, boss. I can't even expect how much bigger also it was. So when you want to create these many sequence of values, very huge data, what will happen? Our Python will try to create all these values, and all these values are going to be loaded into the computer's memory, something called a RAM. Then there may be a chance your program will run out of the memory, because you are creating huge amount of the data and you are requesting the Python to load that data into the memory. There may be a memory problem. There may be a chance to get a memory problem. Then still, if you are not clear with this explanation, now let me press enter. What will happen? Have a look once. Sir, what is happening? What is happening? Sir, this task is not finished, because in the background PVM is trying to create these many values. Even maybe after 1 hour also, still PVM is busy in creating the values and trying to load them into the memory. Maybe there is a chance your program or your system is going to be hanged automatically. You may not work with your system because it is going to run out of memory. Assume a family of 6 members are there. Assume in a family we have a 6 members. Assume, sir, general our provisional requirement oil packet. Every day we are going to use oil packet for preparing so many food items. If I purchase one oil packet, maximum at max 1 week it will come. Maximum 1 week it is going to be consumed totally. That means on an average per a month, for a family of 6 members, 4 to 5 packets, oil packets are required. 4 to 5 oil packets are required. Then per annum 12 5s are 60. Additionally, there may be a chance for festivals. On festivals we are going to prepare so many. 70 packets on an average required for a family of 6 members. Assume like that. Now my question is, if you want 70 oil packets, then is there any fool will purchase all 70 packets at the beginning of the year, and is there any fool can store all these 70 packets in his kitchen? Are you getting my point here? If you have a family of 6 members, on an average consumption calculated per an annum 70 packets are required. Is there any fool can do these type of activity? So what will happen? You are supposed to invest a huge amount. You are supposed to invest a huge amount. Problem number one. Problem number two, really if I purchase 70 packets, the total kitchen is going to be occupied with the oil packets only. The remaining provisionals, where can I keep? So space shortage problem will come. Am I correct or not? Space shortage problem will come. Then generally, if we have a requirement of oil packet, we will order and we will get first oil packet. Whenever it is going to be completed, then we are going to order the next oil packet, we will get the next one. Sir, whenever it is going to be completed, we will order the next oil packet and we will get them. Now tell me, among the two choices, which is the best choice? Sir, whenever there is a requirement for that particular item, generating that value or getting that particular item is the best choice. Now my question is, observe that still PVM is working, boss. The task is not completed. Still PVM is doing his level best to generate all these values to load them into the memory. Is there any guarantee the user who created this syntax, is that person is going to use all these objects at a time? Is there any guarantee that person is going to use all these objects at a time? Is there any guarantee that person is going to open all 70 packets at a time? No, no, no. Per week, one packet only. Per week, one packet if you require, why should you order 70 packets at a time, man? Out of this huge amount of data, if you have a work with only one value, after that next value, after that next value, after that next value, if you have this kind of requirement, why foolishly generating these many values at the beginning, trying to load them into the memory, facing the memory problem? Is it not your foolishness? Then Python is providing a beautiful concept called generator. Hello, boss. Whenever you have a requirement for a value, I am ready to generate. But if you want these many values, I am ready. I can provide, I am ready. But at the beginning, I am not going to generate all the values. I am not going to store, I am not going to load all of them into the memory. But as and when required, you just ask me, you just pinch me, you just call me, I will send you the value instantly. Don't worry, I will take care of internally what is the mechanism. That a beautiful concept is a generator concept, boss. Generator. It sounds like an iterator. Yes, correct only. Every iterator is a generator. Every generator is also an iterator. Sir, to make our own class object of custom class, have you observed that, boss? I got a memory error. I got a memory error. PVM is unable to find that much memory to load these many values. Hello, Pavan, we can't do anything. I'm telling you, I faced a memory error. Then at any cost, I want to generate these many values. I have a work, but all at a time, I'm not going to use one after another only. Then automatically Python is providing one beautiful feature called as a generator. Now come back. What is a generator? Generator is a function only. How to create a generator? How do you create a function? By using keyword called def. Sir, def, I'm going to create one function with the name called display. If you write yield to, sir, what is yield to? It is something like a return to. Sir, the way how this return keyword is going to return one value from a function, are you getting my point here? When you say return to, whoever calls this function, to that calling function, I'm going to return the value 2. yield also it is going to perform the same thing. But any function that uses internally yield keyword inside the body of the function, it is not going to be treated like a normal function. It is going to be treated like a generator. Sir, what is that advantage of yield? Sir, on demand, when user is requesting me the next value, next value, next value, next value, as per your requirement, from that stream of values, one after another, I will return. But I am not going to create all of them at the beginning. I am not going to store all of them in the memory. I am not going to purchase all 70 oil packets at a time. If I require one packet, I will purchase it. When it is going to be completed, I'm going to order. I'm going to get the second one. Same concept generator also. With one example, I can make it clear. Let us open our Python IDLE. You know what is our requirement? The requirement is I want to generate the first 5 natural numbers. But these 5 natural numbers, I don't want to create all of them at a time. I don't want to store them at a time in the memory. Maybe you have a doubt. Sir, 5 values is the very small amount of data. If you store them, what will happen? We will make a trial how to create a generator with a very small amount of data. If we are succeeded, we can convert that 5 natural numbers to 5 crore natural numbers. 5 crore natural numbers, right? So let us see that how to do that. Write a program to generate first 5 natural numbers using generator concept. Sir, using generator concept. Def numbers. Sir, def numbers. So when you call this function, sir, how to call this function, I will tell you. Don't worry about that. I'm going to return yield 1. Sir, another yield. When you call this function for the next time, yield 2. When you call this function next time, yield 3. When you call the same function next time, yield 4. Sir, when you call the same function for the next time, yield 5. Sir, once if I execute this code, you are going to understand that. You may have a doubt. Sir, tomorrow, if I want to generate 5 crore natural numbers, am I required to write 5 crore yield keywords? Am I required to use yield keyword for 5 crore times? Can I write like this? Yield 1, yield 2, yield 3, yield 4, yield 5, yield 6, yield 7. Am I required to write this logic for 5 crore times? Not required. This is a basic program. Try to understand. Then after I will teach you with a single yield, how can I return all the values what you require. Now observe that. Sir, vals equals to numbers, sir. Vals equals to numbers. Is it not a function calling? Sir, it is a function calling. Control will transfer from this line to this line. Because of the yield keyword, what it is going to return? Sir, this function is going to be treated like a generator function, and this vals will become an object called generator object. Sir, what is that? Generator. So generator function will return generator object. Now I have a doubt. Really is that a vals is a generator object or not? Now let us see. Generator, first example. Py generator 1.py. Sir, generator 1.py. Observe that. Sir, generator, this object is internally treated like a generator object. When you call generator function, internally it will return something. Who is going to receive that? Variable called vals. Then automatically vals is going to be treated like a generator object. Now, how can I get these values? Sir, how can I get these values? Very simple. Every generator, sir, every generator internally contains one function called a vals function. You can call next vals. Now that means you are ordering, hello, I want one oil packet. You are going to get your item. Hello, I want another oil packet. You are going to get your product. Like that, when you call next, automatically from the function, one after another, one after another, one after another, the values are going to be returned. So for one next function call, you are going to get only one value. I will look once, I got one. Sir, if you write the same statement for the second time, then I will look once, 2. Then I do one thing, sir, instead of writing these many times for x in range of 5 times, I'm going to call print next of vals, sir. Print next of vals. That means this print is going to be executed how many times? 5. That means the next also is going to be executed how many times? 5 times. When you call next method on the generator object, every time generator is going to return one value, one value, one value, one value. Then I will look once. One, two, three, four, 5. But this is not my actual requirement. Sir, I can put a condition. I want to generate n natural numbers. I will send n value. I will send n value. Sir, n value is something a very bigger number, sir. Very bigger number. Very bigger number. Is my function is capable to generate these many values? Why not? But they are not going to be created all at the beginning on demand, one value, next value, next value. But there all these values are not going to be created at the beginning, and all these values are not going to be loaded into the memory at the beginning. On demand, they are going to be created and they are going to be written. Now, for this, in the body of the function, I can maintain one local variable, sir. I will maintain one local variable. I equals to 1. I have to start with 1. Sir, I have to start with 1 while I value less than or equals to n. Sir, as long as I value is less than or equals to 1, so long can you please return I value. Once value is written, for the next call, I value should be incremented. And can you please check the condition, return that value. For the next call, I value should be incremented. Can you please cross check the condition? Can you please return? So like this, here I am not going to call. Sir, here I am not going to call range function. Here I am not going to call range function. Then I do one thing straight away in the for loop. Sir, straight away in the for loop, I am going to call numbers function. So with which value I am going to call? Sir, these many values I want to generate. When you call a function, sir, this is a generator function. It will return generator object to this place. It will return generator object to this place. Then our for loop is implemented beautifully. From this generator, it will create internally some iterator object. Using that iterator object, it is going to get the values internally by calling next, by calling next, by calling next, by calling next. So we are not required to call next also. We are not required to call next also. Straight away you can print x, sir. Straight away. How beautiful it was. We are not required to call even next also. For loop will take care of everything internally. So మీరు ఎప్పుడైతే ఈ ఫంక్షన్ ని కాల్ చేస్తున్నారో, because of the yield keyword, this function is going to return generator object. For loop లో ఈ generator object కి internal గా ఒక iterator object create అవుతుంది. So iterator object, it is going to represent a sequence of values. So when you call next on iterator object, then Python will fetch the first value from this sequence. Sir, what is that first value? 1. Then automatically next is called another time. You are going to get a 2. Sir, how this is going to be happen? Who will take care of? Our Python will take care of how to call next function. So if all values we fetched, what should I do? Then I do one thing, sleep off some 2 seconds. So from time import star, now observe that generator 1, it is going to generate, otherwise why to waste our time in writing a sleep method, boss? Not required. Now have a look once, these many values, is the PVM is successful in generating these values. Have a look once. Keep on executing. Don't shut down your computer. Even by tomorrow morning also, our PVM will be succeeded, no doubt at all, in generating these many values, boss, because they are all not going to be created at the beginning. On demand, internally for loop will make a call next. When next method is called, one value will be returned. When all the values are fetched, then automatically for loop is going to be stopped. As of now, 89,000, 98,000, 1 lakh, but still so many numbers have to be produced. Is it possible if I do the same work with the list? Is it possible if I do the same work with the tuple? Is it possible if I do the same work with the set? Not possible. That is the difference between traditional, our conventional, not traditional, sorry, I used a wrong word. So our conventional collection objects like list, tuple and set. Our conventional, every day we are using to represent some collection of values, whatever we are using our list, set, tuple. So there is a possibility for the memory problem, right? I hope you got some idea what is a generator. Generator is a function which uses yield inside the body of the function. The advantage is it is used to generate a sequence of values. These many values I want to generate, they are not going to be created at the beginning. On demand, one value, another, next value, then after next value, they are going to be returned. That is the logic behind the generator concept. Now we'll discuss one more and we can close the topic. Let me create a new program. Write a program to generate a Fibonacci series using generator concept. Sir, using generator. Now, sir, when this program is going to be stopped, 7.5 lakh numbers got printed, but still it is a very bigger number. If you want to interrupt this, control C, it is going to be stopped. Now I want to generate a sequence of Fibonacci values, but I am not interested to store all of them at the beginning. I want to implement them with a generator. So listen very carefully. Sir, what is the Fibonacci series is? Observe very carefully. It starts with 0 and 1. 0 stands for A, 1 stands for B. Assume like that. Every time, if you want a next value is a sum of its two previous values. Sum of previous two values is the next value. So every time 1 plus 0, 1. Sir, next value 1 plus 1, 2. Next value 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. 13 plus 8, 21. 21 plus 13, 34. So I hope everyone understood what is Fibonacci series. Sir, it's a kind of mathematical series that starts with 0 and 1. In the series, if you want to generate the next value, or a new value, that new value is the sum of its previous two values. Sir, new value is sum of its previous two values. New value is the sum of its previous two values. Then I want to do this job by using generator. Then def Fibonacci series starts with 0, 1. How many values I will decide. So until that, I'm assuming that keep on executing, keep on generating. infinite number of terms in the Fibonacci, but later we will modify, don't worry. Now observe that what I have to print first. Anyone tell me what I have to print? First I want to print 0. Okay, I have to print a value. Sir, when a got printed, then find out the next value. How to find out the next value? Sum of two values. Sum of two values. Next, what I have to print? B. So it will become A. Sir, A will come to the B place and B will come to sum of previous two values. Now, can you please print A value? So 1 got printed. Find out the next term. 1 plus 1, 2. Then A will come to the B place and B will come to the A plus B value. Then can you please print A value? Now 1 got printed. Find out the next term, sum of previous two values. Now A will come to the B place and B will come to the next value, which is nothing but A plus B. Can you please print A? 2. Find out the next value, 5. Sir, A will come to the B place and B will come to the next place. Can you please print A? Find out the next value, 8. A will come to the B place and 5 should be printed and B come to the next value. Then find out the next term, 13. A will come to B and B will come to the next place. Sir, this is the logic. How to implement that? Now have a look once. Every time what we have to return? Every time we have to return A value. Sir, after returning A value, A will come to B place and B will come to the next term. Sir, how do we get the next term? A plus B, sir. A will come to the B place. Sir, B will come to the next term place. What is the next term? A plus B. That's it. So any function inside the body of the function, if it uses yield keyword, it is going to generate one object called a generator object. So generator object is capable to represent a sequence of values, but those sequence of values are not going to be generated at the beginning. Now we need to put a full stop. I am not going to generate infinite number of values as long as A value is less than or equals to 100. So I am expecting all Fibonacci terms less than or equals to 100. Now I do one thing. Sir, for every x in Fibonacci, can you please print x value? Can you please print x value? Then let me print Fibonacci series. Fibonacci series. Fib. Py. Fib.py. Now have a look once. 0, 1, 1, 1 plus 2, 3, 2 plus 3, 5, 5 plus 3, 8, 8 plus 5, 13. Sir, why it stopped with 89? The next term, 89 plus 55 is almost around 130, right? So it is beyond 100. So when it is beyond 100, I don't want. Sir, when it is beyond 100, I don't want. Is the point was clear? Otherwise, sir, I will decide at the time of calling this function, is there any chance to call like this using walrus operator? Eval input enter a value, like, is there any chance? Let me check. At the time of calling the function, I will ask the user, hello user, can you please enter a value? Up to that value we are going to generate. Okay, it should receive the value. Sir, it should receive the value. So count while A less than or equals to count. Now it is asking enter a value. I want to see all the Fibonacci values up to 1000. How beautiful it was. The last value is a 987 because the 900 and 600 next time is going to be 15. If I run the program once again, I want to see Fibonacci values up to this much. Now within fraction of seconds, our Python program is capable to generate our Python program is capable to generate all the Fibonacci terms. How beautiful it was, right? That's all from my end.